All right, guys, so in this video, we're going to take a look at how to analyze and come up with arithmetic sequences and series. So in the previous section, we had a whole jumble of any type of sequence. It could have been based on squares, cubes, fractions we had, and then we also had the adding, subtracting, multiplying, and dividing patterns we saw. And I kept saying that the adding and subtracting ones were what we call arithmetic, and they're going to be related to in terms of linear equations. So that is definitely what we're going to be doing here. And that's going to be our main focus. We're going to go through these explorations in class, so I'm going to skip over them. And in these, first thing is determining, is something an arithmetic sequence? So in order to determine that, we look for something that's called a constant difference, or a common difference is what you'll tend to also see it as. And it's denoted easily enough by the letter D. So real quick, you just look at your patterns and see, is this something that's added or subtracted? So if I look at these, right, I'm adding 3. 2 to 5 is increased by 3. 5 to 8, increased by 3. So forth and so on. I see that works. So yes, this is definitely one, and the common difference is an addition of 3. Number 2, I can see that this is decreasing, and it's in fact decreasing by 6 each time. Still works out. It's still a common difference. It's of a -6. And we're going to always talk about it in terms of adding a positive or a negative. So I had a common difference of an adding 3 and a common difference of a subtracting 6. If I want to keep in the idea of something being added or subtracted, I can look at number 3 and see that it's going down by 4, then by 2, then by 1. Now I got a fraction. So that's getting a little crazy. So I don't want to do that. But I can also see that it's dividing. If I divide by 2, 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 1/2. So this is not arithmetic. It is not a constant adding or subtracting here. Okay. All right. So that's what we'll work through, do a couple more problems together. And once we know it's an arithmetic sequence, we have this lovely equation, which is actually very similar, whether you realize it or not, to let me get my pen out, to y equals m parentheses x minus x1 plus y1. That is our point slope equation, and this is very similar to it. It's just rewritten in a different format. The m we can relate to as the common difference. This is our x minus x1, and then we have our y values, which are the terms. Remember, if we think back to the fact that I had us look at tables in the sequences and series where the domain was the term position and the range, your y's, were the actual values, it makes sense for those to be your y and your y1 when you're doing things. Okay, so again, we can come up with any rule and write it if we know these 3 things, really. We need to know a common difference, we need to know the first term value, and we may need to know those parts in blue to help us find out any missing piece. Okay. So for example, if I'm looking at this, I have this information that the first term is 3. So that's important to know. So that means a sub 1 is 3. And I have a common difference of 2. So D equals 2. So knowing those things, I can come up with a rule filling in this right here. So let me write that out again. So a sub n equals a sub 1 plus n minus 1 times d. So I can fill in everything I know. A sub n, I'm not quite sure yet, but that's okay. A sub 1 is 3 plus n minus 1 times 2. It's up to you whether you want to put those in parentheses or not. And then you would just clean this up. So I would distribute. I get 2n minus 2, and then combine my like terms. And I get 2n plus 1. And there's that linear format we know. Y equals mx plus b is the same in this arithmetic rule, a sub n, where I can find any term. So the second part says, well, what's a sub 50? Well, just take your rule and plug it in. So a sub 50 is going to be 2 times 50 plus 1. Okay, easy enough. A sub 50. 2 times 50 is 100. Plus 1 is 101. So that is the answer to what a sub 50 is. And if I want to go the other way, if I want to find out, well, what is 49? Well, do the same thing. Just put 49 as your a sub n, because we're trying to find the n in this case. So 49 equals 2n plus 1, and we would solve that. 48 equals 2n, n equals 24. So this is the 24th position, is 49. Okay, so as long as we have a sub 1 and we have the common difference, it's easy enough for us to be able to find those values. All right, if I have to write a rule, from a given sequence, okay, all that means is what you got to do is find the actual pattern, find the difference, you have a sub 1, and then write your rule and simplify it. Okay, so I'll do the first one with you. Easy enough. We see it's adding by 5. So that tells me D is 5. I know the a sub 1 is my first term. So again, if I pull out that rule, and we like rules that have formulas because we can plug in everything we need to know. A sub n equals a1 is 3 plus n minus 1 times d is a 5. And then again, you would distribute and clean that up as neatly as you can. And there's your rule. Okay, so it's nice, easy, quick. Once you're given a sequence, find the difference, grab your A1 and plug it in and simplify. Okay, we'll go through a bunch of examples. All right, next one. What if I'm giving a random term and the common difference? Well, then I got to do a little bit of work. So here I'm given a sub 19. So I know the 19th term is 45, and I know the common difference is -3. So this is going to be a two-parter. Part 1. I need to find A1. Okay, and I have that over here. So I'm going to plug in, again, using this formula. Plug in everything I need to know, or that I do know, I should say. So A sub n, this time there's my A and my n. So I'm using -45 here. A sub 1 is what I'm looking for. The n is 19, because it's the 19th position. And then the d I know is -3. We would do some calculations. 19 minus 1 is 18 times -3 is a -54. Solve for A1, we get 9. Okay, so there's my A1. And then once I know the A1, I can write the rule. That's step 2. Or part 2, I should say. Again, plugging back into here, that basic one. So A sub n equals A1 is 9. That's what we found. Plus n minus 1 times -3. And again, clean it up. And we find A sub n equals -3n plus 12. By the way, and I didn't mention this before, you might see sometimes written the number first. So it might be seen as 12 minus 3n. It doesn't matter the order in which you write it, just as long as you write it in order. At the very last thing, it says, if directed, you may have to graph a table and graph it. I'm not going to go through that step, but you should be able to take 1 through 6, plug it in, find your terms, and when you graph it, you'll find that it does create a line. It is a linear equation. Okay, again, we'll do some practice. And the last thing is, well, first one we had a pattern that we found the difference from. Second one was we were given a random point in the pattern. And now all we got is 2 random points or 2 random terms. So in that case, we have to use systems. So we're going to write a rule. We're going to come up with the system of equations and then actually solve the system. So we got to remember how to do that. So you do one at a time to write your rule. So a sub 7 is 17. So that rule is going to look like this. A sub n, which is 17, equals a sub 1, I don't know, plus n is 7 minus 1 times d. That cleans up, I'm going to skip all those steps, but it does clean up to 17 equals a1 plus 6d. Okay, it's just combining your parentheses. Then you do the second one. Okay, take a sub 26. They're telling me that's 93. Write my rule. And again, what you're going to notice is that your a sub 1 and your d stays part of it. So here is how we're going to solve this. What you're going to notice is that your a sub 1s are nice, perfect, exactly the same, and they will easily cancel out when you solve by subtracting. So if I subtract these, those a sub 1s will cancel, and easy subtract, we get negative 76 equals negative 19d, and d comes out to be 4. Once you have d, we do exactly like we did in the previous, or actually how you do any substitution problem, plug back in and find d now, or sorry, a1 now. So I'm going to plug it into the top one just because it's smaller. So 17 equals a1 plus 6 times 4. And when you go through and you solve that, you get a1 equals negative 7. So now I have the 2 values I need to be able to write my rule. Again, using this formula that we're using over and over and over again. Plug in what you know, and then simplify it. So a sub n equals a1, which we found was negative 7, plus n minus 1 times d, which is 4. And when you go through and you clean that up, you get 4n minus 11. Okay, so when you're given 2 random terms, you got to bring back the fact that you will be using systems. So don't forget about how to solve systems. Okay, and again, we'll practice. And the last thing, I'm just showing it to you to show you, but you're going to be using your calculator. There is a special rule for finding the sum of the arithmetic series. It is the number of terms times the first plus the last divided by 2. You don't need to know the long way because you have Desmos and you're going to be using that calculator. But I did want to just show it to you so you see that it does exist. And in calc and pre-calc, you may have to actually solve and derive where this formula came from. But in our class, we are not going to worry about that. You are just going to use Desmos, plug it in, and then find the actual values, and we know how to do that.